So, last talk before lunch. I'm going to talk about Elasticsearch. My name is Emil, and I'm also going to talk about the Elastic package. And I just want to say that I have nothing to do with either of those. I just like using them and have done so quite a lot. So, Elasticsearch is a search engine. It's a document search database built for search. The clue is in the name. It's distributed. So it's very easy to scale, it's extremely fast, and it's centered around a RESTful API that you can call like any other RESTful APIs, which makes it extremely easy to work with as well, and especially if using the Elastic package. So why should you use Elasticsearch? First of all, because it is fast. It is really, really fast, especially for text searching. It's got a lot of nice functionality built into it. It's pretty easy to use, and obviously because it's open source, and as are people, we like open source. However, there are considerations to not using Elasticsearch. First of all, you should note that it is a non-SQL database. So if you, like me, for instance, love data frames and dislike lists and nested lists and stuff like that, consider using something else. Also, Elasticsearch themselves mention it is built for speed, not total accuracy. However, that has never been a problem to me, but it might be to some of you guys. Also, it can be quite complex, especially all the listed, nested stuff that you work with in Elasticsearch. So Elasticsearch main application is obviously to search. Again, clue is in the name. And it's really good for that, but you can actually also use it to do different analytical things like time series, stuff like that. I'm going to show you an example in just a minute. Both of these things are fast. So the basic concept of Elasticsearch is that it consists of an index. You could compare it to the global environment in R. Each index has different types that could be different lists. Under each type, you have documents, and that would then be your value inside your lists. And the documents then consists of field, which again can consist of other fields. And this is the part where it can get a bit tricky, because you get these nested lists that you work inside. Okay, so to use it in R, what you the only thing you need, obviously, an Elasticsearch database. Somewhere you can have it yourself. I won't go into how to install it, but then you just need the library. You can get it from GitHub or from CRAN. And what that does is it translates R code into JSON and then throws it into Elasticsearch, and then the magic begins. So to give you an example of that, all you need to do in order to use Elasticsearch is load in your package and then run the connect function. And this then just calls a localhost database I have, and that's all. This is all the code you need to connect to Elasticsearch engine. For me, this is just beauty in code lining. And then you're in. To do a search, you need to state what index you want to search on. Let's say we want to search for Twitter tweet index. The type is tweet, and we want to get some documents. And the field we want to use is the message field, where we want to search for the word data. So now we're trying to do a search where we search for the word data in the field message. To translate that into our code, it would look something like this. So this is all the code you need in order to search for this word data in this field message. And in under a second, it has searched through roughly 3.5 million documents, and it returns the top 30 of the almost 10,000 documents it found. And this is really just amazingly fast, and compare it to like SQL searches or stuff like that, it'll take minutes doing the same thing. So this is really one of the great advantages of Elasticsearch. Now you can also do aggregations. I'm not going to go into details about what this is, but as you can see, it's pretty easy. This is all the code you need to produce a histogram over a month, number of tweets per month, and then you run it through the Elasticsearch, and in a flick of an instant, it gives you back some data, and you can throw it into ggplot2, and then this is the date histogram that you get out. And this takes roughly, well, below a second, half a second plus minus, and this is all the code you need to run this, which for me is pretty amazing. You can also combine aggregations and search, so where you say we want to search for this word data again in this field message, and then we want to aggregate how many tweets mention the word data per month. So this is basically combining search and aggregation. Again, this is all the code you need to do that, which I find very interesting. Significant terms is another thing. You can say every time a tweet mentions the word data, what hashtags in this case are used more with those tweets than with tweets that don't mention the word data. This is the code you need to do, and it will produce this result in roughly 0.5 or so seconds. So again, it's extremely fast. You can see what data hashtags are used most in this example, Danish tweets with the word data. So to sum up, Elasticsearch is extremely fast, extremely powerful, and give or take, fairly simple to work with. That's all. Have a good lunch.